folks. Today we're going to talk about neutralization and titrations. We've actually already talked about neutralization reactions back before when we were talking about double replacement reactions and special types of double replacement reactions, but we've never talked about what titrations are. Neutralization reactions are where you take an acid and a base, you mix them together, and water is always one of your products, and then some type of salt always forms. Now remember, in chemistry, salts aren't necessarily our good old sodium chloride. It's always a metal and a non-metal is the general rule when we're talking about salts. So if we were turning this just into a general form, it'd be like if you took HA plus BOH, you'd form H2O every single time, and then you'd have B and A for my salt in here. Here's 3 examples. All of these are ones that have at least a strong acid or base present. This is our typical example that everybody loves to use. You will notice that it does change, and balancing can get sometimes a little bit tricky. My general trick for if you're trying to balance a neutralization reaction, turn water and just write it as HOH. Then you can kind of balance it the same way you've always done with double replacement reactions. But that's just a trick that works for me. So we use the word neutralization reaction, so we know that a neutral solution is pH of 7. We're only going to have that happen if you mix a strong base and a strong acid and it's completely neutralized. So you have to add the same amount of essentially moles of H plus and the same amount of moles of OH minus. So we're going to do a little stoichiometry to just kind of show that. So if I'm mixing KOH and H2SO4 together, and I have my starting amount of volume of KOH and the molarity, and then I just have the concentration of the H2SO4. So let me show the stoichiometry for that. I would, of course, first write my balanced equation, because that's always really important when you go through and do this. So I'm going to go through and start with the volume of KOH, turn it into moles by using the molarity. Then I'm going to turn it into moles of H2SO4 by using my balanced equation. And then I'm going to use the molarity of my H2SO4 to figure out how much I need of the H2SO4. So I end up getting 0.780 liters. And that's how you would do a problem like that. Still just stoichiometry. Now, I also said this video is going to talk about titrations. Titrations are just experimental setups, and it's usually where you're determining the concentration of an unknown acid or base. You might know the identity of the acid or the base, but you won't know the concentration. Generally, you do this by essentially taking advantage of a neutralization reaction. So you take a burette. You'll have seen them before. They have markings on them that indicate the volume. So you might have started up here and then ended up putting this much of what's called the titrant in, which you'll see. I'm going to show you a quick example of that. This is also where we take advantage of the color changing of indicators. So usually if we're thinking about phenolphthalein, which is what you would use in the lab in our class, remember that turns pink when it's basic, but it's clear when it's either acidic or neutral. All right, so let me show you an example of what that would look like. All right, so here's our setup. We're told that this beaker down here is an unknown acid solution of 25 milliliters, and we're also told that it's a monoprotic acid. I'm going to talk about what that means later. I'm going to titrate the solution with a known concentration of NaOH. So in this case, I'm going to use 0.50 molar. And I'm going to use phenolphthalein as an indicator. So again, remember that what I'm going to look for in my beaker here is a very light pink color is what I'm looking for overall. All right, so I skipped forward just so you didn't have to see me click the button a bunch of times, but I've added 16 milliliters of NaOH. You might have noticed if you were looking at this before that the pH has also risen, which means that we're neutralizing more and more of the acid solution that's in here. At this point, I'm going to add smaller amounts of NaOH, and I'm going to look for a big change in pH. So I see even adding just 0.10 milliliters is a huge change in pH. Okay, so with a ginormous jump like that, I really only want to add like about this much more. And lo and behold, I get that nice color change, which means that I've now gone over. But this is called the endpoint of titration. So this is actually how you would use it in the lab. Overall, you'd take this volume of NaOH and go through and calculate it. Just for fun, so we're going to need to keep that 16.25 milliliters in our minds for the problem that we're going to do. But just for fun, I'm going to show you this actually also can over titrate. So if I add that, you saw that it got pinker. It got more of a dark pink. This is one of those ones where generally if you hit a dark pink in the lab, that means that you added too much. You're going to have to restart. Okay, so now using the information from the titration, we're going to figure out the concentration of the monoprotic acid. So what does that monoprotic mean again? Mono meaning one, and the protic refers to protons. So it just means that we use HA for our acid. There's also things like di and triprotic. You can probably figure out what that means. But for example, if it was diprotic, I would say that I would say H2A for our acid. It helps me set up an equation just so that I know my molar ratios. And then there's information from the titration that I'm going to use. So I'm actually going to use this first because I know that I'm going to need to convert this into moles of NaOH. So let me start by doing that. And I'm converting into moles of NaOH, and then I'm going to convert into moles of HA. Now that I have moles of HA, I'm going to convert in by dividing by the milliliters of HA that I was told. And I'm going to end up with the molarity of HA. And that's how I would solve for my concentration of my acid. Now, for your problem at the end of the video, I've provided this for you here. You'll want to start by writing out the equation because that's really helpful when going through. But other than that, feel free you'll go over this in class with your teacher. All right. Have a good day, and we will see you soon.